This enormous German cargo ship was once thought to be unsinkable, which, bold claim, historically speaking. A few nights into its 60-second voyage, in December of 1978, the ship and its entire crew vanished. It would be nearly 20 years before experts would solve the mysterious disappearance of the MS München. The answer was a phenomenon that scientists once thought was impossible, and that all these years later, we still don't fully understand. A rogue wave. Fun fact, they're maybe not as rogue as you'd think. Rogue waves are also called freak waves, or killer waves. At their most dramatic, they can look like a massive, terrifying wall of water that seems to come out of nowhere. But they're not the same as tsunamis. Those are triggered by underground activity and only get big when they reach shallow water. But rogue waves happen on the surface of the water and can form way out in the middle of the ocean. And technically, they're defined as waves that are more than twice the size of the waves around them. In the case of the MS München, that wave could have been more than 80 feet high. But rogue waves aren't always massive. A 4-foot wave could also be a rogue wave if all the waves around it are 2-footers. It's all relative. So rogue waves have long baffled scientists. Typically, ocean waves are surface waves. They form when wind transfers energy to the water. Friction between the wind and the water stretches the surface and creates ripples. And as the wind continues to blow, it catches these ripples. That puts more force on them and creates larger waves with higher crests and deeper troughs. The longer and stronger the wind blows, the larger the waves become, and the farther they travel across the ocean. Eventually, these waves develop a rhythm. They form groups of waves with similar heights and regular timing between them, called periods. For a long time, scientists thought wave activity should be linear and predictable. Early models showed that massive waves were impossible or extremely rare, so people thought sailors' stories of freak killer waves were just tall tales, like the Kraken. Then, on January 1st, 1995, a huge wave came out of nowhere and hit an oil platform in the North Sea. The Dropner platform was equipped with laser detectors to measure wave heights. And while most waves in the area were around 39 feet, this wave was 84 feet high. Luckily, the platform didn't take much damage, but our ideas about waves did. The Dropner wave was one of the largest ever documented, and having it on record confirmed once and for all that rogue waves are real. Plus, our linear wave models were way off. So the Dropner wave launched all kinds of new research about waves. In 2007, researchers put together a list of 50 historical events that probably happened because of rogue waves, including the disappearance of the MS München. And since we knew rogue waves existed, we also wanted to know why. Figuring that out has been tough. Research is ongoing, but we've got some theories. For a while, experts thought the most likely explanation for rogue waves had to do with modulational instability, which is when something interrupts the regular size and spacing of a group of waves. That changes the wave pattern and allows energy to sort of pile up. This energy transfers unevenly between the waves, eventually concentrating into one much larger wave. Scientists can model this happening with water waves flowing in one direction or within a narrow channel where the energy can't escape. But it's hard to explain how it might work in the open ocean, where energy can disperse in all directions. So one skeptic of the modulational instability theory led a team of researchers that looked at 18 years worth of wave data from the North Sea. They noticed two common wave behaviors playing out. The first is linear focusing. When waves that are going different speeds and directions line up just right, they can unite and form a taller crest. The other effect is second-order bound nonlinearities. That's when waves change their shape. Their troughs become flatter and their crests get steeper. And it can make waves 15 to 20% larger than normal. On their own, those effects are just normal wave behavior. But the team observed that when those two effects come together at the same time, they can create a wave that's much, much larger than the waves around it. And we can watch it happening. Scientists think there are as many as 10 rogue waves forming in the world's oceans at any given moment. And they seem to have a sort of fingerprint that we can trace. You see, we can study groups of waves before and after a rogue wave happens, and that can help us figure out exactly how it got so massive and look for patterns that might show when the next rogue wave is likely to form. Then, we can update our models, make more accurate forecasts, and implement better warning systems for ships at sea. And that can be life-saving. The more we learn, the more we can predict what causes these huge waves and when they'll strike next. And maybe, eventually, the idea that a massive, deadly wave could appear with no warning at all will once again just seem like a tall tale. Like the Kraken.